Hi friends, very good evening and thank you for joining in today. Again, can you please confirm in the chat window if I'm visible and clearly audible so that we can get started with the session in a couple of minutes. Okay, I can see myself in the video chat, in the video feed. So any issues or glitches that you may have? Can you just confirm if everything is all right? Basically, then we can get started. Okay, yes, everything is good. So let's get started then. Again, some of us are a little early. Let's wait for others to join in. But in the meantime, I'll take a few questions. Again, this whole session is, again, just to be clear here, let me set the context. We will discuss fundamentally about how to learn AI, data science, machine learning. That's the objective of this Q&A. I see some questions about the diploma program. We have done a live session in the morning hours today, so please go check it. It will be available on our channel. We have answered a lot of good questions about the diploma program, so you'll find some of those there. I might take one or two questions, but we'll focus mostly on the learning part of AI machine learning here. Okay, cool. So 1 second, let's get started here. Okay, so again, I'll also prioritized questions that students have posted in the chat window, right? Again, my team is also posting and collating some of the stuff that students are writing in the chat window here. We will also try and answer the questions that some of the learners have put down in the announcement video. So let's get started here. Somebody who's Elias, is Swift guy, says, I'm planning for a master's in data science in the US next year. How much will this course be beneficial for me to get a job later in the US? So at the end of the day, since you're already joining a master's program, you learn a lot in the master's program. And we've had a lot of students who are either joining MS in CS or MS in data science or MS in business analytics who have taken this course, and that has helped them enormously in performing well in their coursework. So the first thing that you should try right away is once you join your MS program, try and perform well in the coursework, and you can easily do that because what you learn at Applied AI course will be like a superset of what you will learn in a typical master's program. Of course, there will be some concepts in the master's program that we may miss out on because at least in the Applied AI course, our fundamental goal is real world skills that industry cares about, right? So having said that, whether it's your internships or full-time roles, we've had students who are pursuing masters in the US and parallelly taking Applied AI course, not just in US, but also in Europe. So it has helped them enormously in our own experiences. You can see some of those discussions that we've had with previous students on our YouTube channel. And it will help you both in your coursework, internships, and full-time roles after you graduate your master's program. Yes. Cool. So another nice question from Shavak here is, what is the best way to read and update myself on what's happening in the ML world? Very nice question. So here are some strategies that I and a lot of our mentors and teammates, a lot of my friends follow. First thing is I follow all the major research labs and all the research blogs on Twitter. For example, I follow Google AI blog, I follow TensorFlow, I follow Facebook AI Research, Amazon.Science, I follow Yan Lee Kun, I follow Jeffrey Hinton, I follow all the top researchers at some of the top companies, because when they are posting about the cutting edge research work, I take it seriously. I follow a lot of researchers, not just the top notch. I also follow a lot of graduate students, a lot of PhD students, a lot of professors like Lily Fee at Stanford and all these people. So that gives me a good context on what is happening on the cutting edge. Whenever they talk about a paper or any cutting edge work, I take it seriously. So that's one source that I often use a lot and extensively. I also, that will help me on the cutting edge research front. I also keep my eye open for all the new tools that are coming in machine learning. For example, for that, I typically follow the engineering blogs of companies. For example, you can go and check out the AI engineering blog from Google. You can also see similar blogs at Facebook, Netflix, Amazon, all these companies, so that I understand what's happening on the engineering and tooling front. For example, just to give you an example, right? Kubeflow, which is actually a tool that is built by Google and open sourced, has become very, very popular for MLOps nowadays. I see a lot of companies using it. And I learned about it on the Google Tech blog, right? So the best place to keep yourself updated are some of these large company blogs. Of course, also university blogs, to be honest with you. Like if you look at Christopher Manning, who is a professor at Stanford, cutting edge researcher in NLP, when he says something is happening, that's a great source. Also, I look at all the top publications that happen in major conferences. Again, that is more on the research front. In terms of tooling, I always keep my eyes open to new libraries, what people are talking about on Twitter. I use literally whole of my Twitter just for just for learning, and a lot of my teammates also do it. There are also other tools like Archive, Sanity Preserver, and things like that, which are also very, very helpful. That's how I recommend you do it. In a nutshell, the logic is this: you should roughly spend, even after you learn whole of machine learning and data science, all of that, you should at least spend 5 hours every week learning new things. I often tell this to all my mentees at Applied AI course, and even before that, that if you're not spending 5 hours a week constantly learning new things, you'll be a dinosaur in 5 years. It's as simple as that, which means your skills will not be relevant, especially in a field like AI data science, which is fast evolving, right? Okay, so I have some summary of questions that my team has put in here. This is from Ravi Shrestha. I'm an iOS developer with more than 3 years experience. Now I want to switch to machine learning and AI. How difficult will it be to learn through Applied AI course or otherwise? So Ravi, to answer your question, first and foremost, since you're already an iOS developer with about 3 years experience, you know coding. That's the best part. That's a good starting point. We have seen a lot of software engineers, iOS developers, full stack developers. Now on top, so there is a component of the whole data science AI part, which is coding, which you're already comfortable with. The second thing equally important that you have to learn is the core foundational mathematics and the applied aspects of it. And especially as an iOS developer, you should leverage your prior skills. Don't ditch all of the iOS development skills that you've built. For example, with iOS development, in TensorFlow itself, there is a library called, there is a small variation of TensorFlow called TensorFlow Lite, through which you can build state-of-the-art deep learning models that can be embedded on Apple devices, or that can be embedded on Android devices or Raspberry Pis and things like that. So you sit at a very interesting juncture that you already know iOS development, try and learn the cutting edge of data science. You can learn it. Of course, it's not going to be trivial. If it were trivial, what's the point in it, right? It's not, again, this is not like learning a programming language like Java or C++ or C#. It's not that. There is a good amount, if you enjoy mathematics, right? If you're curious on how mathematics can be used, if you have that curiosity, right? You can learn the math. It's not rocket science. You can check out some of the free videos at Applied AI course that will give you a context on how you can learn and how to make mathematics itself intuitive. But since you already have 3 years of iOS experience, you should build on top of it by actually doing projects. For example, you can do cool machine learning. You can use TensorFlow Lite or equivalent technology from Apple or other companies. Build some interesting AI application with iOS development, and then you have a very nice blend of skills. There are very few people who can actually write good machine learning code and also deploy it on an iOS or an Android device. So you have that unique advantage. So you can do it, but you need to put in effort. There are no shortcuts here. I'm not here to tell you that there is a shortcut to learn machine learning. There is no shortcut. Effort is mandatory, right? You have to learn the foundational mathematics. You have to learn programming. If you don't know programming, you have to learn how to apply these techniques. You have to actually build real world portfolio of projects. There is no shortcut from that. If there was, I would tell you. Right, cool. So again, just looking at the questions. So next question is from Shrey Mishra. Again, some of these questions have been collated by my team just so that I don't spend time reading the questions. So very nice. So this is a very nice question, Shrey, that you're asking about graph neural networks. Yes. You're a PhD student and you want to work on GNNs. Again, that's a topic that is at the top of our list. Graph neural networks is something that we will be doing live sessions on in the coming month, or in this month itself. We are already in August. So we'll most likely do about 2 live sessions covering the foundations of graph neural networks and why they're becoming popular now. Again, GNNs or graph neural networks is becoming a very, very hot topic, especially at research level, and also there are a lot of applications of it. I'm not saying there are no applications of it, but we will cover graph neural networks. We hope we can do it in about 2 2-hour live sessions. We'll go, like as usual, we will start with the foundations. We'll go deep into the math. We'll also focus on coding and applications. We will do it from an applied viewpoint, not from a research viewpoint. Okay, but that's at the top of our list. That's one of the topics that we want to cover most likely in this month of August itself, worst case in September. Okay, it's a very nice question. It's in the top of my list already. Okay. Okay, so this is from Vamsi. This question is, I'm one of the course enrolled students at Applied AI course. Okay, do you suggest to do a diploma or a domain certification from NPTEL? So, okay, so again, I have not seen the NPTEL certification itself. I don't know how rigorous it is, so I'll not be able to compare it with the NPTEL certification. But the core essence is this. The reason we started the diploma program is we see a lot of students who are putting in a lot of effort actually learning real world AI and machine learning. Now we want them to all the effort that they're putting in, we want to tie up with a university to provide academic credentials for that. That's one of the fundamental reasons why we started the diploma program in collaboration with University of Hyderabad. And the moment you have an academic program, it's recognized by Government of India, it's recognized by all the world's governments and universities, it's recognized by employers, all of that stuff, rather than a certificate just given by us, right? Because a certificate given by us is just a certificate given by a private company, while a degree given by a top research university is like under UGC norms and things like that. So whatever certificate or program that you're enrolling in, there are 2-3 things that you should look for. One, especially if you're looking for an academic credential, is it accredited by a government organization? That's very, very important. Otherwise, the degree itself is useless. Again, there were some universities in the past who gave degrees which are useless, which are not recognized by UGC. So that's one thing that you should look at. The second thing is, what is the course curriculum and what is the rigor, right? Is it rigorous enough to get you a job? That's the most important question you should ask, because if you're learning these skills primarily to prepare you for a job, are the skills that you're learning really relevant in the industry? That's a fundamental question you should ask, which means, can you actually crack interviews? Can you actually solve real world problems at the end of the program? Even the diploma program that we built along with University of Hyderabad, that has been, while there is a lot of academic rigor in it, our fundamental core philosophy has been that it has to make our students industry ready. That is the top priority. Second priority is academic rigor, right? So any program, not just the diploma of ours, any program that you join, any degree or diploma program, just make sure that the academic structure is rigorous, that examinations are rigorous, and most importantly, what you're learning will get you a job or not. Because that's the core idea behind getting a degree, right? For most working professionals, I'm saying. Cool. Okay, so very nice question. So this is okay. So I'm just going top down. This is from Aryan Raghavan. So the question here is, if you're doing applied AI course, do we need to do problem solving like hacker rank, or can we do that after finishing the course? Okay, nice question. So if you're coming from a computer science background or IT background, so we have a lot of coding assignments in the course itself, including coding assignments where you need to use basic data structures and algorithms. We already have that. But if a learner has time, we strongly recommend them to also code on platforms like HackerRank or any such platform, because more programming never hurts. Programming is a fundamental skill that is needed for data science. But the level of expertise for a data scientist is different from a typical software development engineer, even at the top product-based companies. And even at the top product-based companies, for a software development engineer, you have to be very, very good with data structures algorithms. In the case of a data scientist, you need to know basic data structures and algorithms like hash tables, lists, trees, the basic stuff you should know. You should know basics of time and space complexity, but it will be more from a numerical programming viewpoint. Like for example, can you implement a stochastic gradient descent from scratch? Or do you know, can you use NumPy to build some matrix factorization algorithm? So the programming, while there are some data structures and algorithms that are used there, there is also a lot of focus on numerical programming, because that's what matters for data science roles or machine learning roles themselves. So the hiring bars are slightly different, and the coding skills that are tested are also slightly different. But if you're planning from lead code or HackerRank, great, because having good programming skills is a lifelong skill. It will never hurt you. It's great. And if you can do it, if you have time to do it along with the applied AI course, great, do it. We have had some students who do it after finishing applied AI course also, so that they can crack interviews at better companies. That possibility is always there. Again, we have a lot of optional content in applied AI course itself. For example, even in module 1, we have these live sessions which are optional, but we recommend students who are looking for good product-based companies or startups to actually go through that. There we discuss concepts like dynamic programming, a little bit of trees, right? Some actual numerical programming problems using recursion and things like that. So it's there in the course structure itself. So if you want to learn, it's readily available in the course structure. And we encourage students to practice more programming because we already have 30 assignments. If you want to do more, great. I mean, we can point you in the right direction, or you can just go to LeetCode or HackerRank and start solving all easy and medium problems. That's a good start. I mean, that's great. If you can do it, always beneficial. Cool. Okay, let me just scroll up again. Okay, so this is from Binay Agarwal. His question here is how to participate in a Kaggle competition. Very nice. So Binay, my suggestion for anyone who is participating in a Kaggle competition is, if you're a beginner, your objective should be to learn as much as possible. There are 3-4 things that you can do. First, do rigorous data analysis. That's very, very helpful. Also look at the discussion window that is there, right? All the discussion panel that's there where everybody discusses their approaches, their strategies, their feature engineering, their domain expertise. That is a great place to learn. Number 2. Number 3 that I would suggest is start with rigorous data analysis. Start building simple models first. Don't do a kitchen sink approach where you throw everything. Start with simple models. Try and understand where the model is failing. Right? For example, suppose you build a simple logistic regression type of model and you see some points which are false positives or true negatives. Go debug and say, hey, why is this point a false positive or why is it a true negative? Again, within Kaggle competitions itself, the most popular models are and the most popular libraries are things like CatBoost or XGBoost. Boosting is a very, very popular strategy because it works really, really well. But even after you do boosting, do rigorous analysis on why the model is not working for these points. Again, we have a fully dedicated live session on how to debug machine learning models itself, how to actually spend time doing error analysis, ablation analysis, all of that stuff that is often missed out. If you do that, you can constructively improve your model step by step. So in terms of libraries, the most popular libraries that we see are XGBoost, CatBoost type of libraries. And of course, Keras is very popular for deep learning problems. So your objective, initially don't think of winning. Initially look at it as a way to solve an interesting problem. Write a technical blog. That will be very, very helpful because you have something to show at the end of it. Whatever your rank is, don't worry. Learn from the discussion forum, learn from the mistakes that the model is making, do rigorous data analysis both before you do models and even on the model outputs. And then just write a good technical blog that can become part of your portfolio of projects. Why not? Because most Kaggle datasets are real world stuff, right? So these are some strategies that you can employ. Again, there is a full-fledged live session on how to debug models and continuously improve your models. It's there on YouTube, publicly available. Please check it. We've done this, I think, a couple of weeks back. Cool. Okay, just scrolling through this. So I've answered Binay. Sachin is asking a question about queues, linked list, etc. Again, you can implement all of them. As I told you, more programming never hurts. And especially at top product-based companies, if you're coming from CS or IT background, it's good to know more data structures and algorithms. The reason we are not adding it in an applied AI course is because then applied AI course will just balloon so large that nobody can complete. That's why we have a completely dedicated course called the interview prep course, which is like, I think, 200-hour course roughly, wherein we teach all the data structures and algorithms from scratch. We have 200 solved problems from companies like Amazon, Google, Microsoft, etc. And we have 300 practice problems. So if you're interested in that, you can check that out. But that's a completely separate course because that's designed to help students become software engineers, right? So that's a different course. But if you want to go into the details of it, because we didn't want to combine this 200 hours of course in applied AI course, then it's simply impossible to for anybody to complete, right? So there is no point in it. But if you're a CS student interviewing at top product-based companies, some of these basic questions are asked. Some of them are already covered in the applied AI course, by the way, like dynamic programming, recursion, all these concepts are covered. Some of them which are not there, you can check out the interview prep course. Cool. This is from Mohammad Hassan Rizvi. His question is, what areas, skills to focus on to develop problem-solving approaches for case studies in data science to get a better handle doing different domain case studies? Very nice. I think I got the question that you're trying to ask. So in terms of problem-solving skills itself, the most important thing is data analysis. Are you asking the right questions in your data? Are you doing the right plots? Because just training a model is like writing 10 lines of code. The harder part is understanding why a model is not working or why a model is appropriate for a given situation, or asking, hey, is plotting a CDF of this random variable or this variable or feature, is it useful? How do I debug why this model is not working, or is this metric a right metric, right? So asking a lot of those why questions, right? Why this is working, why this is not working, why is the right strategy? Asking those why questions is how you build a lot of actual problem solving skills. Of course, this should be combined with actually solving real world case studies. That's why even in our applied AI course, 50% of the course is case studies. That's the core idea behind it. You actually learn how to solve a real world case study and you solve an assignment after that, right? So if you're learning data science and things like that, pick up problems from a wide spectrum of problems that you have on Kaggle or elsewhere, solve them end to end. Start from just acquiring data, do the whole pipeline from data acquisition, cleaning, doing exploratory data analysis, building models, debugging models, productionizing models, deploying it on a cloud service, do the whole thing. That's how you build the actual skills that the industry needs and cares about. Cool. Okay, again, just going back up. Okay, so this is another question. I've been in IT development since 95. Okay, currently I'm working in .NET based environment. How difficult will it be to set myself in AI? Okay, as my company is not doing anything in AI. So Sajid, so roughly speaking, 95 is 2005, 2015, 2020. So roughly 25 years of experience. So what we see with people who have that 15 plus years of experience is whatever they're learning, I'm sure you're at a fairly senior position in .NET development. So whatever skills you pick up in data science or AI, try to apply that to whatever project you're currently leading or managing or architecting, right? So the reason being, I'm sure for any client that you work with or for any company that you're working with, in the project that you're part of, there can be some modules. I know your company may not be working in AI, but imagine if you have a client, right, or a customer, you're already building some software for them. Just try to add some machine learning or data science components to it. That's the best way for people with that 15 plus years of experience, which is you already have a lot of expertise. Build whatever you're learning in data science or AI, try to build small modules in this organization that will give you the real world expertise and experience of actually doing actual machine learning in the industry, and then you can always apply outside, right? With that, again, but you need that basic exposure to actually building these machine learning models and deploying it, because with somebody who has like 15, 20, 25 years experience, right? When a company hires you for an architect role, they understand that you come from core .NET expertise, but they expect you to be able to think from a product perspective and incorporate machine learning modules or machine learning systems into it, right? Again, since you come from .NET background, one other logical extension is learn how to do machine learning with Azure, right? Because that's an easier path, because a lot of companies that are using .NET based software also have a high propensity or likelihood of using Azure services. So Azure has a very nice ML studio. You can start building your stuff on Azure Machine Learning Studio itself. That's also a neat path. Okay, cool. Okay, just scrolling up again. There are too many questions. I'll try to answer as many as possible, folks. This is from Harshit. If I put in 20 hours a week, is it possible for me to complete the course in 6 months? I'm working as a business analyst for 2 years. Yes, Harshit. So we have seen average students, I'm not talking about brilliant students, an average student in our program, if they're spending about 12 to 15 hours a week, they finish it in about 6 to 9 months. Again, I'm just giving you these ranges because I want to set the expectation right. If you're putting in 20 hours, very, very likely that you can do it in 6 months. Again, since you're working as a business analyst, I'm assuming you have some programming background or some background to doing data analysis. If you have that, you can do it faster. Right? Like for example, we have had people who are data analysts or business analysts or data analysts who already know some of these things. They complete the course in 4 months, right? Even by putting in 12 to 15 hours. So if 6 months, 20 hours, given your background, is very doable, very, very doable, as long as you're disciplined. That is the key, right? If you can't do 20 hours, it's okay. Do 12 to 15 hours. It might take you a couple of months extra. Don't worry about it, but be disciplined. That is the key, right? Cool. So Tejas has a question, which is, does applied AI course help for data science healthcare domain? So Tejas, as far as our case studies in the course itself are concerned, again, whether you're doing data science in healthcare or pharma or physics or whatever it is, right? The core concepts are more or less the same. It is the domain expertise that changes from problem to problem. So we have some case studies in the course videos which are in the healthcare domain, whether it's about analyzing X-ray scans, whether it's analyzing MRI scans, whether it is actually taking the doctor written prescriptions and analyzing them. All such problems are solved as part of case studies. And we have had a lot of students who actually take real world data sets. Like we had one student who is actually using the X-ray scans of patients who have COVID and patients who don't have COVID, and trying to determine if just using an X-ray scan, which is much cheaper than an MRI, can we determine whether the patient has COVID and what is the severity of COVID. Very nice problem. And some of this data set was collected by hospitals, startups and universities across India that we have collaborated with, and we have students who are working on those problems. So as part of your self case studies, if you want to specialize in healthcare domain, you can solve some computer vision problems and NLP problems, which are very, very important in healthcare. So you have that flexibility. Again, in the course structure itself, we have some case studies around healthcare domain. Cool. Okay, so the question here from Sandeep, which is, are Power BI, Excel, Big Data, NoSQL, are they required for AI and machine learning? Nice question. So the idea here is, look at this. If you know SQL, right, you can use most other data stores. And if you know programming in Python, you can interact with most of these, right? For example, of course, you can do Excel. Excel certainly is not a bad tool. It's a very popular tool for doing basic data analysis, but it's also very limiting. For example, can you plot high dimensional data in Excel? No. Can you do some complex machine learning models and understand feature importance in Excel? You can't. So that's why we focus more on Python, because it's a much more powerful tool. It's because once you know Python, everything that you can do in Excel, you can do it with 10 lines of code, probably even less, right? So it is better to be focused on these generic tools like Python. Of course, Excel is good. I'm not saying Excel is bad. I've seen people do terrific analysis in just Excel, but programming is also a very helpful tool. And in terms of SQL itself, if you know SQL, you can play with most data stores. If you know the foundations of SQL, even some NoSQL databases, you can easily you can acquire data, run a bunch of operations even on Mongo, Cassandra, all this stuff, or even on cloud databases, you can just do it using Python APIs. So if you know Python and if you know SQL, you can do all of this. Again, another question is about big data. Having a basic understanding of big data tools is helpful. You don't have to be an expert, because if you become an expert, you're becoming a big data developer, right? You don't have to be an expert. You have to understand where big data comes, how big data is utilized by actual data scientists. For example, to give you an example there, Spark is the most popular big data tool used by actual data scientists and machine learning engineers across companies. So that's why even in our course, we tell you how Spark works, the intuition behind Spark, and the data structures, the distributed system component of it, without going too deep into it. Again, it's in our course, we don't cover for a big data developer. We are covering for a machine learning engineer or a data scientist who is going to use Spark. Of course, we talk about Spark ML, Spark SQL, all of that stuff. And once you know Spark SQL, once you know SQL, picking up Spark SQL is very easy. It's just a weekend's job. Similarly, if you know how to build machine learning models using Python libraries, doing Spark ML is fairly easy, right? So having these high-level understanding and intuitive understanding along with where and how to apply some of these tools is helpful, no doubt about it. But you don't have to be a deep expert at it, right? Cool. Okay, just scrolling up. Okay, so this is from Preet, which is, I'm also about to complete my Master of Engineering in Automation, Control and Robotics. How to choose case studies which lend me a job as a fresher in machine learning data science. Very nice. So Preet, my suggestion to you is, I don't know what you've exactly learned in your Masters, but if you come from that robotics background, I'm assuming, again, I may be wrong here, I'm assuming that you probably have programmed some Raspberry Pis, some IoT tools, right? I'm assuming that because, I mean, any robotic tool that you have, to control it, right? All the electromechanical controls are done through some electronic circuits and microcontrollers. So if you already know some of these IoT devices or microcontrollers, good case studies for you could be, hey, I'll take something like a Raspberry Pi or an Arduino board or some microcontroller, take a deep learning model or take a cutting edge model in machine learning or deep learning and deploy it on an IoT device. That's a great case study, because now you're blending your expertise that you have learned in your robotics program and the core computational aspects of it with cutting edge deep learning. And those case studies are terrific. For example, we had one of our students, what he did was he actually hacked a little bit with his Maruti car. He actually gathered data while driving in India about how much the wheel is. He just built a simple IoT circuit. He's an electrical engineer by profession. So he built some simple circuitry wherein he said, okay, I put a webcam. My webcam sees the road ahead of me, and it's also measuring how much wheel I'm turning, whether I'm braking or not, and things like that. He collected all this data, built a good deep learning model, and he got like 10 offers, literally 10 offers over a period of like 8-9 months. Because everybody loved this hands-on project that he has done. He has taken the initiative to do it end-to-end, and he actually has very nice demos of it. So you can do something like that in your case, right? Again, you can make it almost like part of your master's thesis if your professors agree to that. Cool. So Ram says, I'm able to implement a model from scratch, but I'm not able to remember. That's a little confusing to me. If you're able to implement a model from scratch, you know how it works internally, right? What is there to remember? You already know. For example, if somebody tells me, hey, can you implement logistic regression from scratch? If I don't know logistic regression and if I don't know how it works from scratch, I can't write the code. What is there to remember? If you know how stochastic gradient descent works, what is the loss, what is the derivative of the loss, how do I do actual gradient descent, how do I do it stochastically? If I know all that, there is nothing else to remember, right? I know the whole math, I can translate it into code. It's straightforward, right? Again, in general, this is a very common question that we see from students that, hey, machine learning data science is a vast area. How do I revise? How do I keep everything that I'm learning? The strategy that we recommend is this. Every week, whatever you're learning in the week, spend a couple of hours, preferably in the weekend, revising everything that you've learned in the week. And of course, if you can revise by actually coding things up, that's great. At least revise the notes that you've written, or revise by solving an assignment or writing some code related to it. Okay, so please do it every week. Then spend at least 1 day a month revising everything that you have learned in that month. 1 or 2 days. Maybe you can take a whole weekend and say, hey, this weekend, or maybe 3 days if required, I will revise everything I learned in the month. Similarly, every quarter, which is 3 months, try and spend roughly like half a week, maybe slightly more than half a week, if required 4 or 5 days, revising everything you learned in those 3 months. So this sort of spaced revision will make sure that, again, you can revise just from the notes that you've written. It doesn't take a lot of time, right? So if you can revise these things, you will have a much broader context. For example, if I don't revise concepts, or for me, revision is teaching itself and answering students' questions and participating in live sessions like these. So even if I don't revise a topic, let's say, suppose there is some topic in machine learning that I don't revise, I forget it. It's just human nature. All of us, if you don't apply it, or if you don't use it, or if you don't revise it, you will forget it. It's just human. So you have to do it more seriously on weekly, monthly, and quarterly basis, especially if you're learning it for the very first time, right? So that way you will not forget it. Again, this is a standard. Again, we discuss this in our course videos also. We discuss how to revise using Feynman's technique, etc. Those are very, very helpful. Cool. This is a question from, one second, sorry. I think I skipped a couple of questions. I'll just go back to those questions. Okay. This is from Santosh. His question is, okay, I'm one of the course enrolled students. Okay, shall I finish and complete the course first and do the assignments, or simultaneously do assignments by progressing through the course? We recommend students, we tell students that, hey, finish this much content. At the end of this content, you will have an assignment. It is better to do that assignment there and then, so that whatever you have learned, this assignment is a form of revision for you. It's a great form of revision because this assignment is based on concepts that you have learned. So you can use that as a way to revise, or you can just revise all the notes that you have written before you solve the assignment. This is what we recommend. But we have seen a lot of students who say, hey, I just want to go through the whole thing first and then do assignments. There's nothing wrong with it. I'm not saying there is anything wrong with it. We have had students who have done phenomenally well even with that strategy. So there is no one right strategy. But remember, if you're finishing all of the course content and then doing assignments, make sure that when you're going through the course content, you're making notes and revising them. That is super duper important. Otherwise, by the time you come to assignments, you will forget everything. Because the syllabus is, again, whatever we try to put in our applied AI course is what the industry needs, right? It is the minimum set of skills that the industry needs from data science folks. Right? That's how we design the content also, right? Cool. Okay, this is from Padmaja. Her question is, do we have any deadlines for assignments in applied AI course? And also help me with the difficulty level of assignments. Very nice question. So Padmaja, there are no deadlines, but if you're enrolled for applied AI course, you're expected to finish all the assignments. There are some optional assignments that you can skip. If you don't want to do it, you can skip them. You have 12 months from the date of joining to complete all the assignments, number one. And in terms of hardness of questions, it depends on where you're coming from. If you have already programmed some programming problems in the very first module, simple, straightforward, right? So the way we decide these assignments is we say, hey, can somebody who has done these assignments genuinely and thoroughly, can they get a job? So the hardness of assignments are simply a function of what the industry cares about. It is actually the minimum bar. For example, I'll give an example, right? So we have an assignment where students have to implement a linear regression or a logistic regression from scratch using SGD. Now, why do we have that? Because that is a very, very often asked question in actual interviews. If you can't do that, the interviewer will simply say, sorry, you just know things as black boxes. So in terms of difficulty level itself, if you put in the effort, they are doable, no doubt about it. And if you're stuck, we have a lot of students who get stuck because some of them come from non-computer science backgrounds, right? We give you hints, we give you additional material, we give you pointers on where you can learn more and try to solve this. So our team is there to help you complete these assignments with lots of hints. So if you put in the effort, you will be more industry ready as long as you've done these assignments thoroughly. Even in the mock interviews that we conduct, right, for students, a lot of these mock interviews are based on assignments that you've done, and the assignments themselves are based on the concepts that you've learned. Again, the reason being, in the actual interviews also, as far as programming questions are concerned, assignments play a very, very important role. You'll see this from a lot of our students that assignments were one of the most important ingredients in their learning journey. And they are, because most of the assignments are actually not just what are asked in interviews, they're also the type of work that you'll actually do in a company as a data scientist. So this is like trying to simulate the work that you'll do as a data scientist while learning itself. Okay, cool. Okay, just a second. Okay, so this question is from Debashish, which is, so can I get internship in top product-based companies if I complete applied AI course? Yes. So you can get both internships as well as full-time roles in top product-based companies. We have had students who have gotten that at various companies, both startups and FANG-based companies. People have done that, and it's doable because the skills that you learn here will be sufficient to crack most of these interviews, right? So, and I'm not just talking about internships, I'm talking about full-time roles also. And we have a lot of actual staff engineers or principal scientists, staff machine learning engineers at some of these top companies who are our advisors, who tell us, hey, these are the concepts that are important because we are using these concepts more and more. For example, graph neural networks came like that because one of my friends who works in a top FANG-like company said, hey, these are stuff that we are now putting into production. These are very, very important. Maybe you want to teach them to your students, right? So a lot of our course content is designed keeping the top product-based companies in mind, because if you're preparing for the top product-based companies, cracking the next set of companies, it will be much, much easier, right? Cool. Just give me a second. Okay, this is Debashish, I have answered. Next question is from Sai Pragnya. Her question here is, currently, I'm doing my PG in computer networks in information security. I have basic skills of C and Python, no code experience. Will this benefit me? Again, depends on, see, at the end of the day, if you want to build a career in data science or machine learning, only then our programs will be helpful. Right now, whatever we are offering, right? Whether it's applied AI course or the diploma. If you're already doing a PG program in computer networks and information security, and if you're planning to look for careers in those domains, maybe our course is not the appropriate course. Okay. There is another course which might help you for software engineering roles, which is called the interview prep course, which is mostly data structures, algorithms, competitive programming, etc. But applied AI course itself may not be the most appropriate course there, or the diploma program, because you're already doing a PG level program or a PG level degree in computer networks and information security. Cool. So the next question here is from Sudiksha. For people who are changing their career from non-IT to ML, how many projects should be done for portfolio? We recommend that you do at least 2 end-to-end projects, right? Preferably at least 1 deep learning, 1 classical machine learning, the more the better. To put it simply, the more the better. But at least 2 projects try and solve from data acquisition to productionizing the model, deploying the model on a cloud-based system, or at least deploying it end-to-end, and writing a good technical blog explaining the whole journey end-to-end. So if you have 2 good blogs, 2 good technical blogs related to 2 solid projects that you have solved end-to-end, at least 1 deep learning, 1 machine learning, more is better. I think you're on a good path, because that way you can showcase skills to recruiters that, hey, I do not come from a CS background, but that doesn't matter because I've actually solved problems end-to-end the way a data scientist would solve. So I have the right skills. That's what a lot of our students who come from non-CS backgrounds or non-IT backgrounds have actually proved to recruiters that they have the right skills. Okay, that's what we recommend. At least 2, more is better. Okay, cool. So this is from an Elias, and the question here is, any interesting resources regarding AI other than applied AI course and blogs? So I like some blogs, by the way. Towards Data Science is a very nice blog that I write, that I personally like. Again, not all the blogs there, but some of the blogs, especially the editor's choice, the long form blogs, I really like them. But in addition to that, research papers are the standard form. I mean, so you can go to all the top conferences. Most of these papers are publicly available, like ICML, ICLR, ICCV, NeurIPS. The simplest way is I just follow a bunch of top researchers and research labs on Twitter. When they start posting good research papers and talking about them, I start reading them. I try to spend at least 5 hours a week on learning new things. Because as I told you, if you don't do that in 5 years, you're a dinosaur. And of all my learning, every year I try to read at least 25 to 30 research papers, because other time I use it for learning tools or other things that I need in my job. But you should at least, reading cutting edge research papers is again not easy. It's not going to be trivial on day 0. This is a skill that I've built, and I typically take about 5 hours to read a good research paper thoroughly. Again, I'm not saying I'll become an expert in that research paper by reading for 5 hours, but I get a good sense of what's happening, what is the context, where does this work, where does this not work, and things like that, right? So that's a great place if you want to keep learning. So okay, just a second. I think I've skipped a question here. So along with applied AI course, what is a good thing to choose? Kaggle competitions or lead code practice? I will say Kaggle competitions because that gives you that gives you an exposure to true data science problems. If you have time, you can also do lead code parallelly, but I would prefer Kaggle competitions over lead code for data science roles. Okay. I'm a Python developer in finance. This is from Manoj. Can you please highlight few areas or applications in finance where ML and AI are valuable? Again, finance is a very, very broad topic. It can be, because finance could mean everything from stock trading to let's say building models to predict insurance claims and things like that. Again, especially because of the new spur in fintech. Like actually one of my friends whom I worked with is now a VP of data science and machine learning at a very, very interesting fintech company, right? Which are building these neo banks. So he tells me about the challenges that they're facing, a lot of very interesting data challenges, because they want to determine, using all the signals they have, whether it's social media data, whether it is all the data that they can access from a customer on what should be his or her credit worthiness. Right? Again, because of fintech and neobanks, new types of banking systems that are evolving now, right? Thanks to RBI and all the regulation. So because of all the spur in fintech, there is a lot of innovation that's happening, and a lot of these fintech companies and especially neobanks are innovating in new ways to build hardcore finance products, whether it is to determine what should be your credit limit, to should we give you a loan for this much amount? What is your loan worthiness? Should we give you a loan for education or for a car, for home, all of that stuff? Those are classical finance stuff. Of course, there is also a lot of machine learning used in the stock trading stuff, but the number of such roles in India are few, because in India, we don't have a lot of quantitative trading per se. Of course, there are roles like that in New York City, London, etc. but much, much fewer in India. Cool. So Karthik is asking a question about will the diploma credits help in an MTech? Karthik, please check the live session that we have done in the morning where I explain this. So as per the new UGC guidelines on the academic bank of credits as per NEP 2020, you can create a bank of credits and you can use it to obtain degrees. We've read this in NEP 2020. So if we start a master's program with University of Hyderabad in the future, one of our top priorities and top requests from the university administration would be to make these diploma program credits that students have obtained to be transferable to a master's degree. And the NEP 20, the National Education Policy 2020 makes that possible. And UOH, being an institute of eminence, can easily do that because they operate at the highest levels of UGC, right? So that's something that we will have to discuss as and when we start offering a master's degree with them. I don't know when that's going to happen because there is a lot of process involved in it, and we are working with multiple universities to see how that is possible. It's a very long process. Even the diploma took us like more than 2 years to get through all the approvals and the academic rigor, academic council, UGC, all of that. So it takes time, but as and when we do it, this will be the top thing. Again, I explained the same thing in the morning live session, so please check that. Cool. Is there no scope for, oh, very nice question. Is there no scope for SDE roles? Should I target MLE roles? No, not at all. Sunil, always I tell this in all of my live sessions. Again, most of our team members also will tell this. Whatever you pick, become excellent at it. I've seen brilliant software engineers in my teams that I've worked with, or brilliant full stack engineers, brilliant database engineers, brilliant big data engineers. They have excelled at that skill. They operate at the highest levels of that skill. They're mostly principal engineers or senior principal engineers or architects at some of the world's largest companies. So whether you choose software engineering, full stack development, AI, machine learning, whatever it is, excel in it. It's not that only machine learning roles are there. That's a fallacy. No. Whatever you pick, excel at it. That's what matters in the long run. The biggest problem that we often see with most people is they don't excel in whatever they pick. I'll give you a simple example. So somebody says, hey, I'm an AWS developer. Great, very nice. I ask them, how does the load balancer work internally? Can we sit down and design a load balancer from scratch? Let's write the high level design. And 90% of actual AWS engineers, when I say AWS engineers, people who have an AWS certification, etc., they don't understand the depth, right? So in addition to having just how to use a tool, you have to know how it works internally. The same is true in machine learning. In addition to knowing how a convolution, in addition to use the ability to use a convolution neural network or a transformer or a BERT model, you have to understand what's happening internally. Because that's the only way you'll constantly be able to push the state of the art and make actually concretely scientific decisions or engineering centering decisions. Because if you don't know how things work internally, how do you make an informed choice on which tool to use, right? So whether you're a software engineer, full stack developer, whatever you are, try to please excel, go to the deepest levels, try to understand things from first principles. Again, I'll give you another example. I've talked to a few Java developers who have been developing Java for the last 10 years. I asked them, how does a specific part of Java runtime environment work? Or how does JVM work? Or if not the whole JVM itself, some components of JVM. And the answers they give are what a fresher gives. And that's surprising. Then I say, hey, you're a Java developer for 10 years, for God's sake. You have to have much deeper understanding how the runtime environments, how virtual machines work. Right? Otherwise, what's the difference between you? If you are just calling a bunch of functions and writing a bunch of classes and writing code, a fresher can do that. You will never grow in your career. So please go deeper, and that's the way you grow. Whether it's machine learning, software engineering, databases, whatever it is. Cool, sounds good. So this is from Ravi. His question here is, do I have to spend much time on Python and SQL models till perfection in applied AI course? Or do you make me apply those concepts in the further modules? Very nice question, Ravi. Again, the way we try to do it is everything that you learn in the previous modules, we make you apply that in assignments. And we use all of that in the course content also. So as long as you're able to complete the assignment that is there at the end of the first module, we have a Python assignment. a mandatory assignment. There are some optional assignments in case you want to do it. And there is an SQL assignment. As long as you can do that reasonably well, not perfectly, you might take little more time. You might have to Google search, learn, figure it out, take time, that's okay. As long as you can do it, you should move forward. Because you'll recap a lot of what you learned in Python programming again. That's why we say, as long as you're able to solve the assignment, please keep moving. Because it's not like a one-shot learning, right? So there are a lot of aspects of Python that you learn when you are going through case studies or when you're solving a slightly more complex assignment, right? So don't get stuck on one concept. Don't go too deep into one aspect. Learn the basics, learn what is needed. Please do the assignment and keep moving. Your depth in Python itself will increase because you're going to do 29 other assignments. Okay, cool. Okay, this is from Rajdeep. Very nice. So please talk about salary expectations for freshers and experienced professionals. Okay, so very nice. So again, okay, let me give you a context, right? Let's talk about freshers first. So if you're a fresher, if you have reasonable data science, machine learning skills, you can comfortably expect a salary if you're joining services companies, right? You can comfortably expect a salary in the 7 to 9 lakhs. Again, I'm assuming you have the right skills. I'm assuming you know the basics well, thoroughly. For a fresher, you can comfortably get around 7 to 9 lakhs in a services company. In a product-based startup, you can comfortably get into that 10 to 12 range, sometimes even to the 12 to 15 range. At the top product-based startups or large companies, both, because top product-based startups pay same as your FANG companies. Of course, some of it may be in stock options, but roughly in the same range. Then you are looking more at the 18 to 20, maybe even 22 lakhs. Like we had a company, a very, very, very interesting fintech startup. And for freshers, they're willing to offer between 20 to 30 lakhs. This is gross. This is not CTC. This is gross compensation, right? Now coming to experienced professionals, right? Based on your, again, unfortunately, some companies look at your prior compensation also. That's unfortunate. But what we see amongst our students who successfully complete, learn concepts and transition is you can comfortably get 50% hike. We often see hikes in the range of 70 to 100%. There are also a few cases who got 300, even 600%, but we don't talk about them as much because they're rarer. But a reasonable hike for an experienced professional is in the 70 to 100%, reasonable expectation. Minimum, I would say, will be around 50-ish. 70 to 100% hike is reasonable. But if you learn the concepts solid perfectly, we have seen 300, 400% for those people who have performed well even in our mock interviews. We tell you in your mock interviews, like very clearly, that this is where you're doing good, this is where you're messing up. Please, that's why we have the first mock interview after you complete 15 assignments, to give you a sense on where you stand, what you need to improve. Right? The second mock interview is at the very end. We tell very, very frankly on your face in a video interview that, boss, this is where you're lacking, this is what you need to do, this is where you stand. A lot of students have taken that feedback very constructively and worked on it. Right? So this is a rough expectation spectrum. Again, there is, like if you're talking about top product-based companies, we've had people who have gotten like 400, 500% hikes also. So it all depends on your skills and also your negotiation ability, right? Imagine if you have 4 offers, very, very competing offers from 4 companies, then you can always bargain more, right? It also comes back to your negotiation skills and your core technical skills. Both of them play a role, okay? That's a more realistic expectation that we have seen from our candidates. I'm not saying you can't get more, but I'm setting you up for a more realistic expectation because there's no point over promising. Cool. Yeah, so this is from Swati. Is ML a subset of data science even if they work hand in hand? Again, the problem is there is a lot of confusion on what is part of ML and what is part of data science, what is part of AI, right? There is a lot of confusion as these fields are evolving every now and then, right? Nowadays, slowly the line is getting blurred because the same company says data scientist, also machine learning engineer, or a data science engineer and machine learning engineer, and they're looking for the whole spectrum, from data analysis to deep learning models, right? So these names of topics, for example, there used to be a topic called data mining earlier. That's almost slowly dying out, right? There used to be something called expert systems. That has died out more or less. So these names keep evolving. Don't get fixated on the names. Fixate on the concepts needed by the industry. Cool. Okay, so this is from Tulio. His name is, my goal is to work as an ML engineer with deep learning. I have a proposal to work with classical ML. Should I accept or aim for a DL spot? What is a good transition plan from classical ML to DL? Very nice question, Tulio. My suggestion to you is, if you already have a job offer in classical ML, take that offer. Because most likely, again, I've seen this in a lot of teams and products and services that I've seen people build, which is most likely in that company, what they're trying to do with classical ML, you might be able to improve it using even simple deep learning models. So you can create that possibility of applying deep learning in the same classical ML role. But instead of waiting for a deep learning role, first get into the role, build your skills. In the team itself, probably you can take a complex deep learning model. Again, the fundamental reason why people don't use deep learning but use machine learning is because of the time complexity and most importantly, the latency requirements of machine learning versus deep learning. But with modern techniques, right, you can take a deep learning model and make it run very, very efficiently and fast. And if you can do that and also create improvement over classical ML models, you're now working in deep learning. And the challenge is a lot of fun. So I would recommend to you to take that job offer. I believe you're one of our students, because I believe we still have a student named Tulio, if I'm not wrong. But anyway, probably it's a very common name in some part of the world. So please take the classical ML role. Don't wait for a DL role. Of course, if you're not happy with this team, if the team says, hey, you can't apply deep learning, just interview elsewhere and join that new team later. As simple as that. But don't leave a job offer just because it is limiting to one area, because you might be the first guy who's applying some state-of-the-art stuff on those problems. Okay, so nice. So Rohit has a question: is the Python programming at Applied AI course good enough, or do we need to focus more? If we need to focus more on what? So Rohit, to answer your question, in Applied AI course we have a lot of mandatory content and also optional content, right? So especially if you're coming from a non-programming, non-IT background, we recommend that once you finish the mandatory content of Python, we recommend you check out some of those live sessions in module 1, because they will help you learn again, we have covered everything that's required in Python for machine learning and data science roles. So there is nothing that we skip. Of course, we may not cover everything at the outset. For example, there are some concepts like object-oriented programming that we have covered we have covered it in live sessions. So like NumPy and other libraries in more detail, or multi-threading, right? So these are stuff that we have covered in optional content. Students, we encourage all of our students to read the optional content in module 1, especially if they're coming from a non-IT background, because that's a great way for them to improve their programming skills. But if you're able to solve all the assignments comfortably in Applied AI course, you have most of the skills that are needed for data science folks. Because we've had students who cracked even top companies by just building their skills through the assignments. So that's very doable. Cool. Okay, so this is from GK. Would you encourage a working professional to opt for a diploma? Is it possible to complete the whole diploma while working, right? I'm worried if thesis would be done successfully with work. So GK, to answer your question, I've also answered this in today morning's live session. The whole diploma program itself is designed primarily keeping the working professional in mind. So if you're willing to put in 10 to 12 hours a week, you can comfortably finish the diploma program in 1 year. But there is also a second clause there, which is, in case for some reason you're not able to finish the coursework or a thesis in 1 year, you're given a maximum of 2 years to complete the diploma program, right? Because we have seen this year, unfortunately, because of the second COVID wave, some of our students and their families fell sick, right? And they could not study and things like that. So we have given them ample time, because in the design of the course itself, the minimum is 1 year, but if you're not able to complete for whatever reason, you have a total of 2 years to complete the diploma program. That's the max duration. Okay, so working professionals, we believe, who are putting in 10 to 12 hours a week, an average working professional can comfortably finish it. In case they can't, you have double the time to finish it, right? Cool. Okay, so I've answered GK's question. Then is Shashank. So what are the highest and average packages students have grabbed after completing the course? Again, it depends on are we talking about India or abroad, right? Because I see IIT saying 1 crore salaries. None of them are in India. That's just a marketing gimmick. okay? Because I've hired at IITs on day zero, so we know the game. So it all depends on where you're asking, but let me give you more concrete numbers. So the median compensation that we see people who successfully complete applied AI course and learn everything successfully, the median compensations for freshers is about 7 lakhs. It changes from time to time. During the COVID wave, it was slightly lower. Now it's all coming back to normalcy, right? So it's about 7 lakhs for a fresher. This is the median, not the average. This is the median, because the problem in averages is if you have a 50 lakhs package, it will make the whole average larger. So we should talk more about medians, okay, for a fresher. Again, the reason being, unlike an IIT or any other university, we don't filter candidates at the input. That is the unfortunate part of modern higher education. That, hey, here is my gate, here is my examination, you have to clear this before you even get an option to learn. That's unfortunate. We want everybody to learn through our program, and their outcomes will depend on how much effort they have put in the course. So in terms of median for a fresher, median number is about 7.5-ish. The highest that we have seen is about 28 lakhs. I'm only talking India, I'm not talking abroad numbers. Only India is about 28 lakhs compensation. And for experienced professions, we had somebody who got like a 7.5x, like 750% hike, which means 650% hike, 650% hike, or 7.5 times their earlier salary. Like the salary goes into like 50-60 lakhs for people with experienced professionals, right? Again, I'm only talking India salaries. I'm not talking about salaries abroad. Those numbers are different. It's unfair to mix both of them and state them because that's incorrect, right? So this is the spectrum that we typically see. Again, even for working professionals, we typically see the median raise or increment to be around 70 to 100%. The minimums that we see are about 40 to 50. Again, depends on how is the job market also, right? These numbers are not static. These numbers keep evolving over time. And the reason is there a hiring freeze because of COVID and uncertainty, or are things opening up? So because of these constraints, things change every time. But the numbers that I've given you are numbers that we've seen in the last couple of years. Okay, cool. Okay, so how can I apply AI in automation testing? Okay, nice, very nice. So in terms of, again, what we have seen in terms of career transitions, right, is people who come from automation testing background or software testing background, there is a new type of role that's evolving, which is machine learning testing. It's something that just started very recently, but we see a lot of potential for people who come from automation testing background to apply the same know-how, because they already know a lot of things about software testing. If they can learn machine learning concepts, understand how a machine learning algorithm works well, it's a very neat transition from a software testing or a software automation tester to a machine learning testing role. That is a growth path that we often see. Now, in terms of applying concepts which are related to machine learning and deep learning to automation testing, there is some research. I've also seen some online tools that generate test cases automatically based on historical data, etc. But it is not yet widely used, right? There are some research papers, there are some startups which are working on it, but it's not yet the de facto standard yet, not yet, right? But in terms of career transition, because as an automation tester, you already know programming. So you can think of two careers. One is machine learning testing, or you can directly go into data scientist role because you already have programming skills to start with, right? Cool. Okay, so next is, okay, very nice. Aishwarya has a question which is, how do we know which domain to choose while starting data science career? What all should be kept in mind while deciding? My suggestion is, if you're just starting a career in data science, go to any domain. It's okay. Because most of the skills that you learn in data science, while there are domain specific skills and domain knowledge itself, if it's the first career transition that you're making, go to any domain, because the foundational skills that you've learned in data science can be applied everywhere by learning a little bit of domain expertise or by learning from domain experts. That's what I would recommend, number one. Number two, if you already have domain expertise, for example, let's assume you worked in banking and financial services, then it makes sense to choose a role in fintech companies logically, because you can now piggyback on all the expertise that you've built. But please don't limit yourself only to some set of companies. I would recommend keep an open mind, Go into any team working on any domain as long as you see the potential to grow in that domain. That's the key here. Because as a data scientist, your skills are domain, they're like horizontal with respect to domains. Because most of the techniques that you apply in medicine or in pharma, you can apply them in finance also. Of course, there are some finance specific details, but you know the concept, so those skills are transferable. Right? So don't fixate just on one domain. If you get a domain of your choice, great, but be flexible with that, especially with your first job in data science. Okay, cool. So Harshit says, on websites like LinkedIn, there are less jobs for data scientists than software engineering. Yes, that is true. I mean, that's a fact of life. Go to any company of your choice, right? There are certainly fewer data scientists than software engineers. That's a fact of life. That's why there are fewer postings also. Forget about postings. Go to any company. Look at the people. Look at how many people are software developers and how many people are data scientists. The data scientists are fewer. But also very importantly, I talked to a lot of these companies. Everybody is struggling to find good data scientists. Just like the way a lot of companies are struggling to find good software engineers. Because nowadays, again, this is a feedback that I get from a lot of our recruiting partners, also companies that we work with, a lot of my friends who are hiring managers and principal engineers themselves, which is, hey, everybody says, I know what a transformer is. I just ask them, how does a self-attention work, and write some pseudocode for it. 99% people can't write it. Like one of my friends who works at a product-based startup, he told me, hey, my first interview question is, let's implement something like a simple decision tree from scratch. And he says 90% of people can't do it in like half an hour interview. And he says, sorry, if you don't know how a decision tree works, I'm not even interested in you, right? So the problem here is a lot of people claim to be data scientists, but they actually don't know how things are working internally. And that is important for most data science and machine learning roles. That's why companies are asking these questions, right? So in terms of the number of roles, surely software engineering roles are more, right? Because the world needs more software engineers today. But if you want to create a space, if you're interested in the math, you're interested in data science, machine learning, there are also enough roles there. The problem of supply demand gap, there aren't good enough data scientists. Like we work with so many companies and they say, hey, can we hire five more people? And we say, for your bar, there aren't enough people sometimes, right? So the problem is not about not having the jobs. The problem is mostly about not having the skills. Again, this is what a lot of industry veterans, people who have been interviewing for over a decade, tell us on day-to-day basis, right? But again, whether you choose software engineering or data science, please excel at it. That's the key. Cool. So this is from Piyush. Is it enough to learn Python for machine learning, or we need to learn R also? So right now, again, a decade back, R was very popular because most of the people who are coming into data science machine learning were statisticians. R was designed by statisticians for statisticians. Nowadays, the impact of R is reduced significantly because while there are some simple tools to do some deep learning in R, more and more it's becoming Python centric. So if you just know Python, you're good enough. You don't have to learn R because most of what you can do in R, you'll find a Python library to do it. And if you know Python, picking up R, doing some basic stuff in it is straightforward. So even if you don't know R, it's okay because Python is slowly becoming the de facto. It has already overtaken R long back. R is mostly used in those companies where they have R code that they've written 2 decades back or a decade back and they don't want to change it to Python, right? Most of the modern implementations of machine learning, deep learning are all, especially deep learning is all Python based. Even some basic statistical techniques and machine learning techniques, people are more and more preferring Python over R. So you don't have to worry too much about R. So this is from Sivakrishna. He says, how cybersecurity and machine learning are interlinked? Very nice question. So in the field of cybersecurity, you're mostly working on large amounts of log data, like access logs of databases or access logs of websites. Now to analyze those logs, oftentimes statistical techniques, machine learning techniques, NLP techniques are what are used extensively. I see a lot of startups, a lot of very big, even big companies which work in data security and infrastructure security, actually hiring a lot of machine learning and deep learning folks. And some of these companies, especially startups, USP is they use state-of-the-art anomaly detection and deep learning techniques to find intrusions or to find any issues with data or security. So the way it's happening is earlier it used to be rule based. Slowly over the last few years, it's all become model based, and I'm sure in 5 years time, most of data security related products will be heavy duty machine learning and deep learning centric. It's already happening with a lot of large products. Very nice. So this is from Shaker. His question here is, how different would you say this course is from MTech at IISc? Companies here offer research engineer, applied scientist position. Would you say the expectation that they can be met with your course? Again, we have about a few hundred students who are master's degree and PhD students at universities like IISc and IITs who actually enroll in our course. And then when we ask them, why are you enrolling in the course? Their answer is, I learn a lot of theory at the university, but I don't know even the basics of how to apply it to solve real world problems. Again, I have been a student at the Institute of Science. I learned a lot of beautiful theory, beautiful mathematics at the university. In my very first job at Yahoo Labs, I had to unlearn a lot. Because what you learn in the university, unfortunately, even at the top universities of the world, except for a very few universities, is not industry relevant. That's why students join. Again, we conduct boot camps at universities like in Institute of Science. We've just finished one boot camp. We're conducting the other summer boot camp at Institute of Science, primarily to educate some of these master's students on how to apply some of these things that they're learning and what does the industry care about, right? So in terms of the difference in the curriculum and stuff, our course is more designed to get you a job at a top company, right? Including research engineer, data scientists, machine learning scientists type of roles. Again, we have had a lot of people at IISc and IITs and or top universities who take our course 6 months before placements because they know that they can perform better in placements with all the knowledge that they gain from the course. While typical universities, including the Indian Institute of Science, give you strong mathematical foundations. We skip some of that. Again, we try to cover a lot of foundational math, but we don't go too much unnecessarily deep unless it is required in the day-to-day world. I'll give you an example. Like at Indian Institute of Science, I learned how to convert from SVM primal to dual. Very beautiful KKT conditions, beautiful mathematics. I mean, one of the most beautiful parts of optimization theory. Great. I have never applied it since then in the last 12 years of my career. So that's why we did not cover it in our course. We kept it as an optional topic that if students want to learn, they can learn. But we don't need that. At the same time, at some of the courses in Institute of Science, they may not go too deep into, let's say, graph neural networks or some of the cutting edge models, right? Like, for example, GPT-3 or GPT-2. They may not be able to cover that because the professors want to teach a specific topic that they are conducting a research in. On the other hand, we teach them because they're actually being applied in the industry, right? That's a fundamental difference. We are very industry centric while academia is very research centric. That's a fundamental difference. And that's a fundamental dichotomy of opinion. Cool. Okay, so Raj has a very nice question. Are there any hurdles for freelancers wanting to transition into full-time roles in machine learning data engineering experience? So not at all. So as long as you can talk about the projects that you've done in your freelancing, if you can write some nice technical blogs going into some of the details, if these blogs are end-to-end, I think there is no disadvantage you stand. Actually, as a freelancer, you might have solved more problems than a full-time employee at another company, right? So realistically speaking, as long as you can show the proof of your work, it doesn't matter. Again, if you don't have the work, if you can't show it explicitly, solve a similar problem and write a good technical blog, build a good GitHub profile. That's good enough. There will be no hurdles as long as you can showcase your work. Okay, so this is a question about writing research papers. Again, I'm not an expert at it, to be honest with you, but typically writing a research paper is very different from industrial research or the hands-on machine learning data science. Because to write a research paper, you take a problem, you take the state of the art, and you try to push the boundary slightly. It's like, imagine if this is the envelope of knowledge that we have. A research paper is all about trying to push that a little more. Right? That's what most research is all about. So research often starts with having a very, very strong foundation. That's why a lot of PhDs actually enroll for applied AI course, because they want to have strong foundations from an applied perspective. Then you find a problem that you're passionate about. It could be a small problem. Try and read all the research that is done on that small problem. Like for example, you might want to come up with better gradient descent algorithms, right? Read all the algorithms that are published in the last decade, all the major, at least the major research work. Then ask yourself, what are the disadvantages of all of these in the real world? And then try to improve that, try to come up with a slightly different strategy to improve and overcome some of the problems. That's how most research papers get published. Again, I would recommend people to publish research work which is more applied. I mean, this is my recommendation. Of course, people might disagree with me. The reason being, a lot of research ends up not being used ever. That's unfortunate, because people write research papers to get a master's degree or to get a PhD. That is unfortunate. And I've done this, by the way. I've done this even in my own MTech, that I've done a research paper that I've never used. I'm sure nobody has ever used that. Okay, my master's thesis was about a randomized algorithm in machine learning. I have never used it. I don't think anybody else has ever used it. But I wrote it because I had to complete my degree, right? It was like a master's thesis, very, very mathematical in nature. Of course, I learned a lot of mathematics doing it. So for me, outcomes were good, but it's something that has never been used. If I have to go back and do it, I would say with all the learning that I've had in the last decade plus, I would say, hey, here is a real world problem that people are struggling to solve. Let me just try to improve that. Because then I know that if I even solve that problem partially, there will be thousands of data scientists that will use that. Again, by the way, XGBoost came from a PhD thesis. XGBoost is a very popular boosting library. It was built based on a PhD thesis at the University of Washington. So that's a great PhD thesis used by almost every data scientist that I know of, right? So cool. So Aditya says, what is the contribution of statistics in deep learning? Modern deep learning is not very statistics driven. It's mostly mathematical optimization driven. It's not very statistical driven. Unfortunately, we don't have a lot of deep rigorous theory behind modern deep learning. Again, there are a lot of research labs that are working on it. There's something called as lottery hypothesis and things like that, where they use concepts in basic probability theory to prove some very interesting properties about deep learning algorithms. But modern deep learning is all about building complex networks, operating on large data, being able to run this on large amounts of compute resources, and using variations of gradient descent with innovative architectures. There is very little statistics. Of course, people do use statistics or statistical, like people use concepts like KL divergence, right, to create a loss function. KL divergence is a concept from statistics. Or people might say, hey, I've already trained my deep learning model, I want to measure its performance, right? You can use concepts from statistics like that, but statistics is not the foundation of modern deep learning. It's more mathematical optimization, large data sets, large infrastructure, large compute resources, and a lot of CS stuff. Cool. So very nice question from Naveen. So Naveen says, how to prepare a good clean resume which shows your previous experience and ML concepts learned. My suggestion is as follows. At the very top, instead of writing objective and all that, which nobody reads anyway, try to focus on the one or two good projects that you have done. Please give a link to the technical blog. Please give a link to the GitHub profile, right? That is a great way to showcase your actual skills, because tell what the blog is about and say this is a 2000 word blog, it's a technical blog. Give links to that, because recruiters do tend to read them before the interview. At least scan them, if not read the whole thing. If it is 3000 words, people may not have time to read it, but at least people will scan. Number one, if you have applied some of the machine learning in your role, whatever role you're in, right, try to also focus on that and say, hey, I've applied, let's say, a convolution neural network to a small problem, or BERT to a small problem that I'm working in my current role, and it has created X% improvement. Talk in terms of improvements that the system has created, and then go to your regular resume. You can actually fit all of that in maybe 1 to 2 pages comfortably. Focus on the machine learning projects that you have done, the GitHub profile, the links. Most importantly, if you have applied it to your current role, talk about the impact of it, right? So I think that's a better way to showcase your skills, especially machine learning skills if you're a working professional. Cool. I think I've answered a good chunk of questions. Again, these are collated by my team. Okay, so let me go into the chat window now. So this is from, this is a question which says, is it mandatory to learn research papers if we are preparing for machine learning or data science? you should be able to read cutting edge research papers because the field itself is moving so fast. Yes, you should know how to, at least some research papers. For example, you should know how BERT works. BERT is a research paper from a couple of years back. You should know how a transformer works, right? So you should know how a graph neural network works. Again, we explain all of this in the course videos, and some of the live sessions that we conduct is about, we take a research paper. Like for example, we took, I think earlier this year, we took this research paper called Vision Transformer. It's a paper that was published in Jan of this year, if I'm not wrong. We took that paper in March or so. We explained that whole paper intuitively, logically, so that people can understand how transformers can be also used in CNNs. Can also be used for computer vision tasks instead of CNNs, right? So it's a very important ability, especially at top product-based companies, because they expect you to have the ability to read a cutting-edge paper and implement it. Okay. So very nice. So this is from Anil. Anil says, can we become a good data scientist after getting a job as a data analyst? What are the skills required for transition? Very nice question, Anil. Typically for a data analyst, what companies are looking for is basic statistical analysis, some data analysis tools, maybe a little bit of scripting in Python, and maybe a couple of machine learning models, right? That's what most data analyst skills typically talk about. From data analyst, if you want to go to a data scientist, you have to learn more machine learning and deep learning techniques. Your breadth of knowledge should increase. So should your mathematical depth. Even the statistical techniques and machine learning techniques you have learned, you have to understand how the mathematics work, whether can you implement some of these, not all, but at least some of these techniques from scratch. Do you understand how each of these techniques work in different scenarios? For example, what happens to logistic regression if I have a lot of outliers, right? Similarly, what happens, why should I prefer logistic regression over random forest? And under what real world circumstances will I prefer logistic regression over random forest? Right? So these are some real world whys and hows and wheres that are extremely helpful in your preparation. So if you learn more, you need to gain more breadth of techniques, more mathematical depth, and more programming proficiency. If you have that, you can crack it. You can easily even internally transfer from data analyst to data scientist. We see that students doing a lot. So this question is about how frequently will we get support from applied AI course if you're stuck in code. Again, if you're stuck with any code, you can just shoot an email. You can expect an answer to the email in a few hours if it's daytime. Worst case is 24 hours. There is no limit to how many questions you can ask. We'll keep giving you hints. We'll keep giving you direction till the time you solve it, right? So, I mean, the path is very, very simple and straightforward. Again, if you submit your code, if there are some errors in that code, we will point to them and say, hey, here is this error, please go and change it, right? So we are here to handhold you in this process of learning, and we understand students come from lot of backgrounds, and our objective here is to help everybody succeed, not leave anybody behind, as long as they're working hard. Again, we believe very strongly that every learner deserves a good teacher and mentor, okay, as long as you are disciplined with your learning. If you're not disciplined, nobody can help you. But if you're disciplined, if you're working hard, if you're putting in your effort in the right direction, we want to help you. So do we have the same content for interview prep course in the diploma program? No. So they're two different things. The diploma program is diploma in AI and machine learning. The interview prep is like a full, like we could do a diploma in software engineering with that, right? So that's a completely different content, primarily for software engineering roles. There you study everything from time and space complexity, data structures, algorithms from scratch. We solve 200 interview problems at top companies and then 300 practice problems. That's a completely different course. That's got nothing to do with AI machine learning. That's for software development roles, fresher level software development goals. Okay. Okay, so this is from Elias IMSP. I want to get deep into data analysis and understand models, but I'm under job pressure. How to manage understanding and get job early, any smart way? Again, my suggestion to all students, especially working professionals, is try and put aside dedicated time to your learning. Like we tell this to almost all of our students, which is try and put, let's say 2 hours in the morning or 2 hours in the evening, whatever works for you. Try and put in at least 2 hours a day, either maybe 1 hour morning, 1 hour evening, 2 hours morning or 2 hours evening. Put that time, block everything else, block social media, block all of that. Please avoid distractions in those 2 hours. If you have kids at home, try and do it before they even wake up so that you can focus just on your learning. So 2 hours of consistent effort a day, do it for 6 months, 9 months, you'll start seeing results which are miraculous. What you need is the discipline of putting in those 2 hours every day. Right? If you do it, again, the best way that I do it is I say, hey, morning this time to this time before my son wakes up, this is my time to get the hardest work of the day done. And I try to get it done 90% of the times. That's the best strategy you have. Right? It works. You just have to be disciplined to wake up and sit in front of a computer, avoid WhatsApp, avoid all social media, sit down and learn. It works magically well. Again, you'll not see the results on the first day or second day. You do it for 2 to 3 months, you'll see magical results happen. You'll see work getting done. Cool. Again, somebody is asking, what is the difference between AI diploma and AI course? Please go check out the live session that we have done today morning. The very first question we answer is that. So please check that. Cool. Okay, this is from Kamal. His question is, do we need to learn data structures and algorithms in Python for data science interviews? The answer to that is, depends on the role that you're interviewing for and the company that you're interviewing for. If you come from CS background, if you come from IT background, if you're interviewing for a machine learning engineer role or software developer machine learning type of roles, in the top product-based companies, you have to know basic data structures algorithms. Even if you don't come from CS IT background, you have to know some basic data structures algorithms which are used in machine learning, like trees, because we use KD trees in K nearest neighbor, hash tables, basic recursion, right? These are basic stuff that you should know, right? Most questions will be around that. Again, nobody will ask you very advanced data science or very advanced data structures or algorithms for most data science roles, right? So we try to cover most of what is relevant for data science roles in our applied AI course, of course, with more academic rigor in the diploma, right? But everything is covered there. That if you have successfully completed the applied AI course, understood all the concepts, done all the assignments, I mean, there is nothing that's stopping you. Okay, so Ajay says, I've taken applied AI course earlier. I'm now working in a good analytics startup. Very good to hear that. As a senior machine learning engineer, very happy to see that, Ajay. Good to hear that. How to prepare to get into top product based companies. Very nice. So my suggestion is, since you're already working at an analytics startup as a senior MLE, you should try for senior machine learning engineer roles at top product based companies. There are 2-3 things that you should build. One is more mathematical depth, because you will expect that in top product based companies. A little bit of, because you already have work experience as a senior MLE, they would expect you to have machine learning design skills, which means they'll give you an open-ended problem and say, hey, how do you solve this problem? What are all the components that you'll build? How do you deploy these models? So there'll be a lot of focus on the end-to-end, especially on the deployment part, some of the distributed systems like Spark ML and things like that. And of course, there will be mandatory coding rounds. So please improve your data structures algorithms. If possible, a little bit of machine learning design skills to get into senior machine learning roles at top product based companies. Again, very happy to hear this. So the question here from Ashok is, I'm not from maths background, how it plays a role in the course? Again, whole of machine learning is applied mathematics and statistics. Ashok, I would recommend one thing. We have a lot of free videos where we explain basic mathematical concepts intuitively and explaining how they're actually applied. There are a lot of free videos at Applied AI course. Just create an account, register, and just check out some of the free videos. You will understand how simple techniques like simple histograms, or how simple techniques like drawing a line or drawing a plane can help you immensely in solving actual machine learning real world problems. So please check out the free videos. They will give you that perspective. They'll give you the perspective on how some of the simple math, calculus, simple concepts that you have learned in high school, linear algebra, probability, how all of them can be used to solve cutting edge machine learning problems. Again, interesting machine learning problems. Just give me a second. I'm sorry, just give me a second. Any recommendations on how to prepare for AWS or Azure requirements? Very nice question. So my suggestion is this. If you know the basics of one of these, like for example, if you know how EC2 works, you can easily pick up how Azure works. That's why in our course videos, we cover the basics of cloud computing, the basics of NoSQL databases. We cover those basics in the course. We actually have a lot of code walkthroughs and walkthroughs on how to deploy a model on EC2. And we're also planning to add SageMaker soon. Again, the reason we're adding more and more AWS content is because we have expertise in AWS. Right? We're also collaborating with some folks at Microsoft to create content in the future about Azure. So once you know about one of these, you can easily, like what some of our students have done is this. They've learned the basics of Azure they've learned the basics of AWS from our course. And if a role says Azure, right? So they'll just create a free account on Azure, play with it for a week or so, because they know the concepts. Because the concepts don't change much. It is just the code which changes slightly. The implementation changes slightly. The concepts don't change as much. So then they play around with whatever tools are there in Azure and they say, hey, this is a small thing that I've built in Azure. Again, I'm not an expert, but I know some of the basics of AWS. I can pick it up as required. Okay, cool. Okay, folks, I think we have spent about 90 minutes in this session and thank you very much for participating. I've had a great time interacting with you, answering your questions. Again, thanks to my teammates, especially Murli, who has been my co-founder Murli, who has been collating all these questions. Thank you very much. And please understand that we may not be able to answer all the questions because we had like 250 people just a while ago. And it's hard to answer everyone's questions, but we try to collate all questions and try to answer as many as possible. We'll also conduct some of these live sessions in the future. Just let me see, is there... So 1 second. So, hey, I believe there is a message from Saurav, which is, I studied BE in mechanical engineering and had 4 years of experience in aerospace domain. Oh, very happy to see that, Saurav. And you've enrolled for applied AI course and got a job. I mean, I think you put this message earlier. I believe one of my teammates also said congrats. Very happy to see that you're from a mechanical engineering background, 4 years experience in aerospace domain, completely different from machine learning, and you've successfully made the transition. Very happy to see that, Saurav. Very happy. Congratulations. Very, very happy. Again, stories like yours, to be honest with you, literally make our day. I was literally giggling like a child inside because, wow, here is a guy who comes from completely non-coding background, completely different domain, and we have played a small part from our side to help this student succeed, Saurav specifically. Thanks, Saurav, for participating and literally making our day, to be honest with you. And thanks to all the students for participating, all the potential learners, everybody who's trying to learn, whether you're a student or not, doesn't matter. We want everybody to succeed. That's what matters. Please put in your effort in the right direction. Most importantly, please be disciplined and regular in your learning. All the very best. Anything that we could not answer in this session, please go to Applied AI course. We have our email. We have our phone numbers there. Please shoot an email. We'll try and answer as many questions as possible via email. Just give us some time. We might take some time if you get a flood of emails, but we'll try our best to answer all the questions. Thank you very much, folks. Thank you very much. Bye-bye.